Hello everyone. I'm Lamine IGHIL AMEUR. I'm a researcher in soil mechanics in CEREMA. And today we'll make a presentation on evolution of the RGA phenomenon under the climate change, awareness, adaptation and prevention.
You need to do first on the computer and then it works. I don't know why. Now you can try to work.
Okay, thank you. Here you have the main points that I will develop in this presentation. I will focus on these 5 points. I will start with an introduction on the shrinkage swelling phenomenon, which is called in France RGA, retrait-gonflement des sols argileux. And here you have an illustration of the complete cycle of this phenomenon. The shrinkage swelling phenomenon of the clay soils is related to the deformation, the ability of deformation of soils under hydric conditions of drought and precipitation. Here, for example, you have an example of an idealized element of saturated soil. First, it will be subjected to drought. Then here you have a combination between shrinkage and under drying path and evaporation until shrinkage limit. And after that, we don't have shrinkage, we don't have deformation, but the evaporation still continues until the final state of the soil. And after that, we have a wetting path. Under wetting path, we have another phenomenon, which is the swelling, which is the deformation, also the deformation of the soil, the ability of the deformation of the soil under precipitation. And here we have water infiltration during 2 phases, you can see here. Here we have the final state of this, second part of the phenomenon, which is non-reversible. Here we don't find the first state at the beginning. And under climate change, the consequence is to disturb the condition, the meteorological condition of drought and precipitation. This affects the hydromechanical properties of clay soils, and this induces damage on buildings built on this kind of soil. Here you have how we characterize this phenomenon in the laboratory. For example, we collect natural clay soils in the site, for example, using a mechanical shovel. And after that, we can make in the laboratory some tests. For example, here, simplified shrinkage swelling test to measure here the maximum deformation in swelling and in shrinkage path. And here, for example, you can see that the deformation, the ability to deform in shrinkage is twice more important than swelling. This is why we have a problem. We have a problem under this phenomenon during drought and during desiccation of the soil. Here another kind of the laboratory test we can make on clay soils using the DVS. DVS is dynamic vapor sorption apparatus. Here we can simulate several drying wetting paths. As you can see here, for example, we can repeat cycles. Here is repeated 3 times. And after that, we can, for example, plot the results in terms of change in mass as a function of an estimated soil section using the Kelvin law here given by this equation. For example, here we have different soils, natural soils collected from different boreal. It's number 1, 2, and 3 at the depth of 1 meter. and you have for each boreal two samples, A and B, to verify the repeatability of the test. Here you can see that the repeatability is, we can observe it between each two samples of the same boreal. And another observation we can make here is the initial state of the sample. Here we have three different levels of the initial water content, and this can be seen here in terms of the results. We have a gap between these samples in terms of change in mass. Now I will go to the second point, which is how the RGI phenomenon evolves under climate change effects since 2015 in France. Here you have some observations. We have severe and recurrent drought during a long period, sometimes including the winter season. We have recurrent heat waves and disrupted seasonality. We can observe too that since 2022, cracks and damages of infrastructures have a tendency to appear quickly. And in terms of insurance damage compensation, drought insured damage compensation increases yearly and becomes the first insured natural hazard in France. Here I give you some examples of the infrastructures that are concerned by this phenomenon and this evolution, houses and roads. Here you have some post-2015 highlights, and I will detail these points in the next slides. For the first one, we can observe geographical extension of the RGI phenomenon in terms of exposure. Here you have the two maps that will be developed by my colleague Sébastien in the next presentation. Just to see that in 2010 we have a part of 24% exposed moderately and high to the shrinkage swelling phenomenon. This value increases and reaches now 48% of the part in France. Another observation is about the number of houses, individual houses, exposed to this phenomenon. You have here a comparison between 2017 and 2021. Here we had more than 4 million houses, and now we have more than 10 million houses. This represents more than half, 1 in 2 houses in highly exposed to the RGA in France. And you have the localization of this part in France. We have also droughts. Drought becomes the costliest natural hazard these last 10 years. You can observe it here in this illustration. Drought has a part of 54% in terms of insurance compensation since 10 years, the last 10 years, and 42% since the beginning of the regime of natural disaster, regime CatNat in France. In the other side, you can see here, for example, the difference and the comparison between before 2015 and after 2015. You have the increase of the charge in terms of drought since 2015 to reach 60% compared with the other natural disaster cost. And here you have, for example, specifically for drought, the top 10 of the costliest droughts in France, and we have 6 of these top 10 which are located after 2015. Another point here to observe is about drought gradually spreads across the whole of France. To observe this, you have 2 maps here, a comparison of average annual charges by department before and since 2016. Here we can observe that in this map, we can observe that on average since 2016, in these 3 regions, you can see here, average annual charge have increased tenfold. The charge is multiplied by 10 for only these 3 regions. Another observation is about soil desiccation propagation. You have soil desiccation propagates deeper, more than 3 meters. Here you can see here, for example, an experimentation we made on the road by monitoring the soil by water content sensors. You can see the red points here until 4 meters deep depth. And you can see here that we measure desiccation until 1 and 2 meters in 2020 and more than 3 meters in 2022 drought. Here in the other side, you can see here, for example, the results of field monitoring. You have in blue rainfall and in red one volumetric water content sensor that measures this parameter at depth of 0.5 meter. And you can see here the values during the drought of 2022. And during winter, we have also drought during this period with a decrease of volumetric water content. And I will finish with this point here to talk about an exceptional drought in 2022. You have here in the left side the map of recognized and unrecognized municipalities CatNat drought 2022. In green, you have the accepted request, and in red, you have non-accepted request. And we have numbers here. We have near 7,000 requests accepted, which is a record since 1982. And here in the right side, you have a distribution of drought CatNat decrease in different periods, including the 2022 year, the drought of 2022. And during this, you can observe, for example, that we have entire metropolitan territory which is concerned, affected, more than 92 departments, including 3 new departments for the first time in history, which are Côte d'Or, Finistère, and Corse du Sud, South Corsica. Now I move to the third point of this presentation, information and awareness on the RGA consequence. In the left side, you have a distribution of average annual costs due to drought by department. It is a projection by 2050, and you can see here the maps given the situation in the future, with the increase of the charge related to the drought. And here in the bottom, you have, in terms of total charge, you have the total charge related to drought will be multiplied by 3 and reaches 43 billion euros. And here in the right side, you have a result of an opinion study made by Opinion Way for Home Serve to ask house owners in France about drought, about RGA and cracks on their buildings. You can see here that we have 30% of people that answers that they are not aware of this, of the consequence of drought in France. And you have only 19% that answered they try to anticipate the problem. This means that we have to do more and better to inform and aware people on the consequence of this phenomenon. To do this, we have to talk about these consequences. For example, in the case of house and buildings, we take into account the structure, the clay soils, the type of clay soils, but also the environment. And the environment, we have to take into account the influence of the vegetation, because the roots of the vegetation increase the desiccation in this type of soils, and the influence of water cycle, because if we have an inadequate drainage system, we'll have problem in this clay soils during drought period and during wetting period. Here you have some examples of origins of structural damage due to the drought in clay soils. You have, for example, here inadequate rainwater evacuation system. You have, for example, the influence of vegetation and construction defects. And here in the bottom you have some cracking mechanisms due to the deformation of the soil related to the shrinkage swelling phenomenon. Here I move to the case, in the case of roads. We monitored the road in 29 before with watermark probes until 4 meters depth. During this period, from May to November in 2009, and you can see here the section evolution of maps, evolution maps as a function of time. And the blue means the soil is wet, and the red one means that the soil is dry. Here you can see that the area that concerned by this evolution of deformation of the soil is near the shoulders of the road. This is why we define here a model to explain that the zone, the critical zone under the road are located here under the shoulders of the road shoulders, as you can see here, because of the exposure to the evaporation and maybe when we have vegetation with a root, the accentuation of the desiccation in this zone. This is why we have to take into account, in the case of the road, all these factors of drain within cycles, meteorological conditions, the nature of the clay soils, the evaporation in road shoulders, the presence or not of the vegetation close to the road. Now for the fourth point. Does prevention allow to reduce RGA vulnerabilities? The answer is yes, earlier as possible. Why? Because, for example, here you have an illustration in an individual house. In 2015, we have the appear here of one small crack, which is not treated, and you can see picture after picture the evolution, the propagation of this crack, and the appearance of new cracks here, as you can see, to move to cracks with a dimension in centimeter. Here another example, when we don't manage correctly drainage close to the foundation, you can see here, for example, what we can obtain during winter. We have a soil which is oversaturated, and in this facade here, we have in the soil hydromechanical collapse, which means that the structure moves. And inside, we can see here, due to the differential settlement, displacement in about 5 centimeters here. And the problem induced, like we don't close the door, for example, or the windows. To do this prevention, we have here summarized some points. For example, due to the vegetation. If possible, keep all vegetation away from the facades and the foundation, for example. Related to the drainage system, for example, regularly check the condition of sanitation networks to prevent leaks, for example. And when faced with sloping ground and exposed bar perimeter, apply necessary recommendation for peripheral horizontal waterproofing and adequate water drainage. I move to the last point of this presentation about new approaches and the innovative RGA project for the adaptation of the existing buildings and roads. Here you have the max solution, which means maison confortée par humidification. The aim of this, the principle of this solution is to rehydrate the soil by the rainfall collected during drought period in localized soil in the bottom of the foundation. Here you have an illustration of this technique that we tested first during 4 drought period since 2016. And here you have the summary of the results. You can see in the top the meteorological results, data, and in the bottom you can see the section of the soil with different probes. The color that you can see here, the curves in color that you can see here. And in red, you have the evolution of one crack, which is monitored also during this 4th period of drought. And the aim of this solution is to stabilize the evolution of the crack, existing crack. You can see here, when we made humidification of the soil, we avoid the opening of the crack. This is the stabilization of the existing cracks. For example, on the road, we tested the horizontal sealing of roads, shoulders, technique to limit the evaporation in this zone. I explained in the beginning that this zone is critical. And the desiccation is very important in this zone. This is why we tested this horizontal sealing. You can see here the method we used with 0.3 meter of thickness of this sealing. And we monitored this with section probes until 4 meters depth. And we have done this in 2019, and until now we don't observe cracks or any deformation related to different settlement in this part of road. And you can see here the result in terms of section, evolution of section as a function of time during these 3 periods of drought. Including 2022, which is an exceptional drought. And last project that I presented here It will be beginning this year for 5 years. Sorry, it's written in French. This project is named CESAR, surveillance étendue du niveau de l'humidité des sols pour l'adaptation à la résilience face au changement climatique, that we will made with RGA. You can see here some informations. And the aim of this project is to develop a network of stations in France that measures the water content in the soil at the depth of 2 meters. We will make about 50 stations with a representative localization to be representative. We will the aim of this project is to anticipate the risk of drought and the consequences on buildings, on the roads, for example. Why? Because currently we have only 19 stations managed by Météo France that can measure the relative humidity of the soil, the water content of the soil, until maximum 30 centimeters in depth. And I presented before that the soil desiccation propagates more than 3 meters. This is important to get this measure at this depth. This is why we will do this project to be able also to study the correlation between soil, vegetation, atmosphere conditions by getting this data. And thank you for your attention.